Hello students, it's Dr. Sansom, and I want to do this practice problem for you about heat and enthalpy. So we have this situation, we've got 36 aluminum soda cans and they're at room temperature. We want to cool them down to 0 degrees Celsius so they will be very refreshing. And we have some ice. It's initially at a temperature of minus 18 degrees Celsius. And then they've given us a bunch of data here that we can use. So the first thing that we have to think about happening is our soda cooling down. So we're going to have a Q for the soda cooling. We're also going to have a Q for the aluminum cans cooling. We have to treat them separately because the specific heat of aluminum is different than that of soda. We're also going to have a Q for the ice heating up to get to 0 degrees, and potentially also Q for the ice melting. And if we add all of those together, we're going to have 0 because of the conservation of energy. Okay, so first looking at our soda, the soda cooling is going to be an MC delta T. We're also going to have an MC delta T for our aluminum and an MC delta T for our ice heating up. The only one that's going to be different is our ice melting because that's a phase change, so it's a change in potential energy. So let's start with our soda cooling down. We know that we have 36 cans of soda, and each of them has 355 milliliters. So assuming that we have a density of 1 gram per milliliter, that's 12,780 grams. We'll multiply, assuming again that this soda has the same specific heat as water, which is a little bit of an assumption, but making that assumption. And we know our delta T is going to be minus 25 degrees Celsius. That is our Q for the soda cooling. We're also going to have the Q for the aluminum. And in this case, each can has 12.5 grams of aluminum. So that's 450 grams of aluminum, and the specific heat is 0.897 joules per gram degrees Celsius, and our delta T again is going to be minus 25 degrees Celsius. So those are our two first things, Q for the soda and Q for the aluminum cans. Now, the thing that's going to be tricky about the ice is that we don't know exactly how much we're going to have. So I'm going to add my MC delta T, but my M of the ice is my unknown. My C for the ice is going to be 2.11 joules per gram degrees Celsius. And my delta T for the ice, assuming that it all comes up to 0 degrees where it can melt, is going to be positive 18 degrees Celsius because it started at negative 18. And finally, we're going to have the Q for ice melting. I'm going to go ahead and change. They gave me the delta H of fusion here per mole. And I'm going to change from moles into grams. We know that there's 18 grams in each mole for water. And so that gives me 0.333 kilojoules per gram. So now I'm going to keep my M for the ice, but I'm going to multiply by my delta H. I'm going to change it into joules to match everybody else, 333 joules per gram. And when I add all of those together, that's where I'm going to equal 0. Okay, so now I have a fair bit of algebra to do. What I'm going to do is work out each of these things separately and then we will deal with the algebra. So I have 12,780 times 4.184 times negative 25. So that gives me for my soda negative 1,336,788 joules. And then I have 450 grams times 0.897 times minus 25, and that gives me negative 10,091 joules for my aluminum cans. And now I'm going to have 2.11 times 18, which is 37.98 times M, plus 333 times M, and all of that equals 0. So now I'm going to combine my numbers, negative 1,336,788 plus negative 10,091 gives me negative 1,346,879 joules, plus I'm going to combine my numbers attached to my M's, 37.98 plus 333 gives me 370.98 times M, and that equals 0. So arranging it to the other side, 370.98 M equals positive 1,346,879. These are joules per gram. So my units are going to work out just fine. And now I'm going to divide both sides by 370.98. And my mass is going to be 3,630 grams. Okay, so I figured out how much mass of ice I need, but they asked me not in grams, that would be too easy, and instead they asked me about 5-pound bags of ice. So I'm gonna need to convert my 3,630 grams into pounds, and there's 454 grams in 1 pound. So that comes out to 8.0 pounds of ice. And since these come in bags of 5 pounds, that'll be 2 bags of ice. So keep this in mind next time you're planning yourself a get-together. You actually know how to calculate how much ice you need to buy to keep your soda crisp and refreshing. I hope that helps you in your life, and I hope you have a great day.